In this lesson, we're going to be talking about the properties of logarithms, and the properties of logarithms should feel a little bit familiar. They should seem kind of like something else that we've done before, but just a little bit different, a little bit backwards, okay? So when we look at this, the first one says this. The product rule basically says if I have two logarithms being added, okay, so here I have two logarithms being added together, and those logarithms have the same base. Here I have base b, and here I have base b. I can rewrite that as one logarithm of the two things being multiplied. So in other words, I can rewrite it as log base b of x times y as these two things being multiplied. So if I have two logarithms being added and they have the same base, I can just rewrite it as one logarithm and multiply instead. Okay? And that should seem familiar because it's very similar to our rules of exponents. When you think about your rules of exponents, if I had something like this, if I had x to the fourth times x to the fifth, here when I multiply, I add the exponents, that's x to the ninth, okay? So it's the same as our rule of exponents, but it's reversed, okay? With exponents, when I multiplied, I added the exponent instead. Well, with logarithms, when I'm adding, I'm going to multiply instead, okay? So it's the same rule, but backwards. And when we look at this second piece, the second piece of this thing saying that I can take log base b of x times y and split it up into log base b of x plus log base b of y, it's just saying that we can use that rule in reverse, okay? So when you think about the properties of logarithms, when you think about this property, you want to think about it this way, okay? You want to memorize it the first way that it's listed, but just remember that you can do this rule in reverse if need be. Okay, and it's the same thing here when you think about the rules of exponents. There was one place where we used this rule in reverse, and when it was doing things like this, like the cube root of x to the 11th, something like that, I would break down into x to the 9th times x squared so that I could take the cube root of each, okay? So any one of these rules can be used in reverse, and that's all this second piece is saying. So again, the properties of logarithms, it's just like our rules of exponents, but it's backwards. Okay, so with rules of exponents, when I multiplied, I added the exponents. With logarithms, when I add, I multiply in the logarithm. Okay, but again, we can do that rule in reverse. That's all the second piece is saying. But remember the rule the first way, and just remember you can use it backwards if you need to. All right, for example, I'm going to look at these. Here I've got log base 2 of 7 plus log base 2 of 6, and I can rewrite that as log base 2 of, well, that addition becomes multiplication inside the logarithm, and 7 times 6 is a 42. And that's it. If I look at the next one, log base 3 of x plus log base 3 of 5x, again, if this is addition, I'm going to rewrite it as one logarithm. It's log base 3 of. It becomes multiplication inside the logarithm, which is a 5x squared. The next one. It's log base 5 of x plus 1 plus log base 5 of x minus 3. I'm going to rewrite it as log base 5 of, well, that addition is going to become multiplication inside the logarithm. When I multiply, I have to FOIL or distribute here, so that's going to end up giving me an x squared minus 2x minus 3. Okay? Again, we can use this rule in reverse, so here's what it's going to say. If we want to use this rule in reverse, it'll say expand. It'll say to expand each. And so I'm going to take this logarithm, and I could split this into two logarithms now that are being added together. So I'm going to do log base 2 of 7 plus log base 2 of x. So again, I can use the rule in reverse. Every once in a while, that is useful. Okay? Same thing here. I have three things being multiplied. When you think about it, it's 3 times x times x. So I'm going to write it as three logarithms being added. I'm going to do log base 3 of 3 plus log base 3 of x plus log base 3 of x. Okay? And there are a couple other things that we can do with this when we look a little bit closer. Not anything that we might do right now. So for now, we might leave our answer this way. Or you might notice that, you know, because I have two of these log base 3 of x's, I could rewrite it as 2 log base 3 of x. Okay? But we'll get to why that is a little bit later when we learn a couple more of these properties. For now, you might leave your answer this way. Okay? Based on this second step. All right? And then the last one, there's a couple different ways that we can split up when we have numbers. With 21, there's not too many factors here, so I could really only split this into log base 5 of 7 plus log base 5 of 3. And this last one, this is the main use, or used to be the main use for expanding these things. See, calculators used to not be able to do logarithms, and so we would have to look these up on a table or using a slide rule. And the fact of the matter is the table or the slide rule wouldn't go all the way up to 21, but it would have log base 5 of 7 and log base 5 of 3. So by splitting this up, we could look each of those up on the table or on the slide rule and then add the decimals together. Okay? Kind of useless now because we have calculators. All right? So just keep that in mind. And again, 9 times out of 10, we're going to be using the rule this way. Okay, we're going to use these to write these as a single logarithm. That's typically how we're going to be using this. Expanding these, not nearly as useful. Okay, so keep that in mind. Practice the rule more this way. It's more important doing it this way than it is to do it this way. Okay? If I look at the next rule, shouldn't be surprising. We've got the quotient rule for logarithms here. And basically it says this: if I have two logarithms being subtracted and they have the same base, I can rewrite it as one logarithm of those two things being divided. So subtraction becomes division inside the logarithm. Again, I want to memorize the rule this way. Okay, that's how I want to think about this rule. And just remember then that I can do this in reverse. Okay, that's kind of an afterthought. All right, so I memorize the rule the first way. I just remember that I can do it backwards if I need to. All right. So again, just like properties of exponents, remember with exponential functions, when I divide two things, I subtracted the exponents. Well, now with logarithms, when I subtract, I change it to division. It's the same rule but backwards because these things are inverses. All right. For example, when I look at something like this guy, and the order here is very important. Notice it's in the example up here, it's x and then minus y, so it's x divided by y. So the order there is very important, so keep that in mind. So for this one, because it's log base 2 of 24 minus log base 2 of 8, I have to do the 24 divided by 8, so it's going to be a log base 2 of 3. Okay? Same thing with the next one. It's log base 3 of x minus the log base 3 of 5x, so I have to do the x divided by the 5x, which is going to end up giving me a 1/5 because those x's are going to cancel. Okay, so make sure you divide this in the appropriate order. Okay, and then the last one here, it's log base 5 of, it's got to be the x minus 1 divided by the x squared minus x. And now from here, remember this thing that's inside here, I can simplify this guy a little bit by factoring. See, the numerator is an x minus 1. The denominator I can factor out an x. And this was the other method we had for dividing. What happens is the x minus 1's cancel out, like I'm reducing the fraction. This leaves me with a log base 5 of 1 over x. And that's it. Okay? So do simplify the division that's inside there. Just like the previous rule, we can use this one in reverse. If we want to use it in reverse, it'll say to expand. So this division, I can split it back up into the subtraction. Do log base 2 of 3 minus the log base 2 of 5. And again, the order here is very important. It's got to be the log base 2 of 3 minus the log base 2 of 5. Okay, it can't be the other way around. All right. Same thing here. I'm going to split this up. So this would be a log base 3 of 2x minus the log base 3 of 7. But now from here, I have a logarithm that has multiplication in it. I can split this first logarithm into log base 3 of 2 plus the log base 3 of x. All right, and it's important when the directions say to expand, we want to make sure we expand it completely. We want to essentially make this thing as big as possible. All right. Same thing with the next one. It's log base 5 of x squared minus the log base 5 of y. And now from here, the x squared is like x times x, so you could split that up into a log base 5 of x plus a log base 5 of x. And then again, we could combine those into a 2 log base 5 of x. For our purposes right now, you might not recognize that until we do the next rule that we're about to do, and that'll make it a little bit clearer as to why we do that, okay? But technically, this would be our answer down here, okay? The last rule we're going to look at in this set is the power rule. And basically it says this. It says if I have multiplication here, I'm multiplying by r, I'm going to make that an exponent inside the logarithm. And again, this is just the reverse of the properties of exponents, Okay, with exponents, when I raise something to a power, when I have exponents, I multiply them, all right? Well, here multiplication is becoming an exponent instead. So we're doing the very reverse of everything we did with exponential functions, okay? Again, we want to think of the rule this first way, all right? So think of the rule this way. And just remember, as an afterthought, that you can use this in the reverse, okay? Out of all the properties we looked at so far, this is the one we'll use in reverse most often, okay? So here, when I look at this guy, again, that multiplication, I can just change this multiplying by a 3, and I make it an exponent inside the logarithm. So that's going to be 2 to the third power, and 2 to the third power is just an 8. So I simplify the exponent, okay? Same thing here, multiplication. That can become an exponent inside the logarithm, so it becomes log base 2 of x to the 4th, which I can't simplify any further. Here, same thing. I'm going to bring this up as an exponent. Multiplication becomes an exponent inside the logarithm. So now I have x minus 1 squared. Well, just remember to do x minus 1 squared. That's x minus 1 times x minus 1. So you have to distribute or FOIL, which gives you the x squared minus 2x plus 1. Okay? And so that's what's going into my logarithm here. Okay? Again, using the rule in reverse, I can take that out of the exponent if I want. If I want to expand, I want to stretch this thing out, so I'm going to turn that exponent back into multiplication, so it's 2 times log base 4 of x. And now you can see why we were getting 2 of those things before. If you think of this in terms of multiplication, it would be log base 4 of x plus log base 4 of x. There's 2 of them. So here's the shortcut we would be taking. Okay. Same thing here. I would bring this guy out front. That would be a 5 log base 3 of 2x. And now from here, I could expand this further because I have multiplication. That would be a 5 and then a log base 3 of 2 plus a log base 3 of x. And then from here, what you could do is you could distribute this thing if you wanted, all right? And you could rewrite this as 5 log base 3 of 2 plus 5 log base 3 of x, okay? And either one of those answers would be acceptable in my book, okay? The last one, again, we're going to bring that guy out front, so we're going to turn that exponent back into multiplication, so it becomes a 2, and then a log base 6 of an x plus 2. And don't be fooled and think you can expand this further. Addition inside a logarithm doesn't allow us to expand at all. That one has to stay the way it is, okay? If we take a look at a couple where we're just doing a little bit of everything here, so we're kind of tying all these rules together. If I look at this one, we want to write each of these as a single logarithm. Again, this is the way we're typically going to think of these rules. So here, I start in terms of order of operations. I've got multiplication, and I also have addition. So I follow order of operations. I'm going to take care of that multiplication first. So the multiplication, remember, can come up as exponents inside the logarithms. So that's going to give me a log base 2 of x to the third plus log base 2 of 3 to the second, which is a 9. Now I take care of that addition. Remember, addition can become multiplication inside the logarithm. So that becomes log base 2 of 9x to the third. And that's it. All right, so we're just using those properties to kind of condense this thing. In the next one, I do the same thing. Follow order of operations. I start inside the parentheses. In the parentheses, I've got multiplication, addition. I'm going to do the multiplication first. That multiplication comes up as an exponent, so it becomes an exponent inside the logarithm. So it's going to be a log base 3 of x to the second. Now still inside the logarithm, I'm going to go ahead and do that addition. Remember, addition becomes multiplication inside the logarithm, so it's going to become log base 3 of 5x squared. Now I'm done inside the parentheses, so outside the parentheses I can go ahead and do this step. I can bring this guy up as an exponent. Multiplication becomes an exponent inside the logarithm, so it's log base 3 of 2 to the third, which is 8. And now the subtraction becomes division inside the logarithm, so it's going to be log base 3 of 5x to the second over 8. All right, so we're kind of bringing all these rules together to reduce this thing and condense it one step at a time. And really, you should see how powerful this is. When you look at the original example, look at how much stuff we had to deal with versus what's left once we simplify this thing and have it written as one logarithm, okay? Expanding each, again, you won't have to do this as often, but let's practice it a little bit. So inside, because we're going backwards, we kind of go backwards through of operations. So I'm going to undo that multiplication and split into addition first. So that's log base 4 of 3 plus log base 4 of x squared. And notice I kept the x squared together because now I can use that rules with the exponents. The exponent becomes multiplication outside the logarithm. So doing that rule backwards, I can bring that 2 out as multiplication. And that's it. Same thing with the next one. I can undo the exponent here, so I'm going to bring it out front. I'm doing that first before I do what's in the parentheses, because again, I'm going in reverse. I'm working backwards. It's log base 2 of 2x. Sorry, log base 5 of 2x. Clean that up a little bit. And now from here, I can split that multiplication into addition. I can just leave that 5 on the outside and do it this way. Or if you decide to distribute that, that would also be fine. You can leave that like this, or we can distribute. And some of you, as you start to get really comfortable with these and do more than one step at a time, are probably just going to apply that exponent of 5 to everything and go right to this answer down here. But I would accept either one of these, either leaving the 5 on the outside or distributing it to each, okay? And then the last one, here I'm going to split this division up first, so I'm going to split up the division into subtractions. That's going to be log base 6 of 3x squared minus log base 6 of y. And now from here I'm going to split up the multiplication that's in this first logarithm. That's going to be log base 6 of 3 plus log base 6 of x squared. Again, I don't split up the x squared because I'm going to deal with the exponent using that rule instead. And now I can bring that 2 out front as multiplication, so it's going to be log base 6 of 3 plus 2 log base 6 of x minus log base 6 of y. And now it's expanded completely. Okay? So again, typically we're using these rules the first way we did it, where we're writing them as one logarithm. That's the way we want to memorize the rule. Expanding just means, hey, we can use this rule in reverse if we need to. Okay? But again, properties of logarithms, very similar to exponential functions, just in reverse. So when we're adding 2 logarithms, I can change it to multiplication inside. When we're dividing, I change it to when we're subtracting, I change it to division inside. And when we're multiplying, I can change it to an exponent inside. Okay?